Okay, welcome back, guys. We're at day 5 right now. Here's the deal with day 5. We've had all these different types of figures we had formulas for. Shouldn't I be able to find the area of any type of polygon, no matter what it's called? Right? What about a hexagon? Why didn't I give any love to a hexagon? Octagon? Pentagon? Why can't I find the areas for those? And that's what we're going to do today, but there's no formula. Okay, I'm not going to give you a formula. Instead, what we're going to do is we're going to break each of the polygons up into triangles, which you do have a formula for 1/2 base times height. All right. And just to preface this at first, we are going to find the area of just regular polygons. And if you remember regular polygon, all sides are congruent and also all angles congruent. Okay, so real quickly here, we're not going to find the area of these first two figures, but I just want to point out a couple things that are going to help us out. Okay, so we have our hexagon right here over to the left, our 6-sided hexagon. First thing, since it is regular, all 6 of these angles are congruent. So if you know they're congruent, is there a way to find out one of the angles? And the answer is you're darn right. All of them form a circle, which I know there's 360 degrees. I can divide by 6. I'll get ahead of myself there. I can divide by 6, and each of those angles is going to be 60 degrees. Okay? Also, because it is a regular polygon, all of these segments are congruent to each other. These segments, if you'd like to know, it's not a big deal, but if you'd like to know, these segments right here are called radii. They come from the center drawn to the vertex. Okay, they're called the radii of a circle. Okay, so any regular polygon, I can find one of the angle measures, one of the central angle measures, and then remember all the radii are congruent. Okay. So this brings me to my pentagon over here now. I just didn't want to mark up the diagram more, so I'm going to start fresh on my pentagon over here on the right. What we can do is take a look. If I said, hey, could you find the area of this pentagon? Maybe down the line by the end of these notes I would, but take a look. You have 1, 2, 3, 4, 5 triangles right now. All of them are congruent because this is a regular figure. So just writing some thoughts down here, the area would be 5 because of the 5 triangles times the area of one of them. And since it's a triangle, I can do 1/2 base times height. Okay? So that's our plan for these notes is if you want me to find the area of something, I'm going to find how many triangles I can make, find the area of one of them, and multiply by how many there are. Now, let's just quickly, before we get to an actual example, let's take one of these triangles. How would you find the area of the triangle? Well, it would be base, 1/2 base, and then I'm going to have to draw in the height from here. Height's always perpendicular, and we're going to have to find somehow a way to find that, the way to find the height. And the different types of triangles we're going to see here, okay, we're going to see 30, 60, 90 triangles. Yes, we're going to see 45, 45, 90 triangles. And we're going to see equilateral triangles. Okay? All different types we've seen before it can deal with. So do I have a formula for you for the area of a polygon? Nope. Here's what we're going to do. We're going to take the number of triangles and multiply that by 1/2 base times height, the area of one of them. Okay, that's all we're going to do today. Okay, that is all we're going to do. So let's try it out. So find the area of this equilateral triangle given the radius. Leave your answer in simplest radical form. It's been a while. All right, so what I'm going to figure out is, all right, from the center, how many triangles can I draw in? And I'm going to be able to draw in 3 of them. Okay, so the area here is going to be 3 times 1/2 base times height of one of them. So let me highlight one of them in green right now. Okay, how do I find the area of that triangle? All right, let me draw it out too because it could get a little messy. All right, there's the triangle. I know the sides are going to be 4 and 4 here. Now, could you find this angle measure here? This is what we talked up above with the hexagon. Yeah, I can. It's going to be 360 divided by, let's see, there's 1, 2, 3 angles. So that angle is going to be 120 degrees. Everyone good so far? All right. Here is my base. Here, when I draw it in, will be my height. So I need to find the length of the base and the height I just drew in, which is perpendicular. If you're thinking about it, and you're probably correct, that height bisects that angle of 120 degrees. Okay, bisects it. So now I'm talking about 60 on each side. And yeah, you guys got it. Take a look. This is a 30, 60, 90 triangle. Okay, this is a 30, 60, 90 triangle. So let's get our rules out. 30, 60, 90, x radical 3 and 2x. All right, my question to you is, all right, where is the 4 across from? The side of 4. That's across from the 90, so that's going to go here. Where's the height across from? The height is across from the 30, so the height would be 2. Okay, height equals 2 here. Now I still need the base, right? Well, the base is across from the 60. So what do I do with the 2 to get to the side across from 60? I multiply it by radical 3. Okay, so this is 2 radical 3, that piece. And if you're thinking again, well, does the height bisect the base? Yes, it does. The height bisects the base. So I have 2 radical 3 and 2 radical 3 on this side as well. Okay, so everything I need right now is filled in. So let's go back to the formula up here. 3 times 1/2. The base is 2 radical 3 plus another 2 radical 3. So 4 radical 3. And we just found the height to be 2, the side across from 30. Okay, so see what we're doing there. You're going to get a 30-60. You may have a 45-45. All right, it's going to get nuts. So now simplest radical form, I have 3 times 1/2 times 4 times 2. I'm going to keep the radical 3 in my answer because it says simplest radical form. So 3 times 1/2 times 4 times 2. That should give me, let's see, 24. Half of 24 is 12 radical 3. So there it is for that one. Okay, 12 radical 3. All right, hopefully we're good there. Okay, because that's all we're going to do is start breaking these up. Okay. All right, next up, I have my find the area of the hexagon. Okay, hexagon. So let's get a formula here. Hexagon, I'm going to be able to make 6 triangles times the area of one of them. All right, let's focus on the area of one of them right now. And I already kind of gave you a little something here, right? So let me draw this triangle again. So that's 3 meters. Okay. Before I draw the height in, can you guys find what that angle should be? 360 divided by 6 now. That angle is going to be 60 degrees. I asked that because when I draw the height in now, it bisects that angle of 60. So now I'm talking 30 here, 60 down there. And remember too, the 3 is for AC, the entire base. You just bisected it. So now I'm talking about 1.5 here. Okay, because remember, it bisects the base. So let's get out our chart so I can find what the heck the height is. Okay, so it looks like 1.5 is across from what angle? The 30. You're looking for the height, which is across from the 60. So I take 1.5 and I multiply it by radical 3. Don't need to go any further. I got the height and the base that I need. Go back up to the formula. 6 times 1/2. Base was originally 3, and we just found the height to be 1.5 radical 3. Directions say round to the nearest tenth, so everyone's going to their calculators right now and multiplying everything through. Okay? And it ends up being to the nearest tenth, 23.4. We did have units here, so let's square units for area. Okay? Not too bad, right? Okay. Let's deal with the square now. Find the area of that square. All right, well, we know I'm going to end up with 4 triangles. Let's change colors. So 4 triangles times one of them. The area of one of them. All right, let's draw one of them out. Okay, 7 centimeters here, which means this radius is also 7 centimeters. All right, you guys, how about that angle right there? That's going to be 360 divided by, now I got 4 of them. So, hey, that's going to be a right angle. When I draw the height in, that 90 gets cut in half. So now we're working with 45, 90. Okay. And I need to find everything here, huh? Okay. So I need to find the height and the base here. Okay, so here we go. I got 30, 6, oh, not, what am I doing here, huh? One job. Just in that habit. 45, 90. X radical 2. All right. So now I'm looking at, let's see, where's the 7 across from? In the 45, 90 triangle, where is that 7 across from? It is across from the 90. Whew. Whew. This is rough here. Rough. Okay, so now, if that is across from the 90, I'm looking at for the 2 sides across from the 45s, right? Whew. All right. So if 7 is equal to x radical 2, and I need to get the x by itself, right? That's what's underneath the 45s. I need to get the x's by themselves. You want to divide both sides by radical 2. Okay, divide both sides by radical 2. That's some wacky decimal, right? So that's across from the 45s. Now I know some of you may say, well, didn't earlier in the year you said we couldn't have a radical in the denominator? Yes, absolutely, that is true. But here's my thinking. Since we have to round our answer to the nearest tenth, it's not going to really matter if we take it out of the denominator or not. Okay, because we're still going to get a decimal answer we need to round. Okay, so just a heads up on that. Okay, so that would be the height is 7 radical 2, and across from the other 45 is 7 over radical 2, which means this is 7 over radical 2. Okay, you guys ready here? This is going to be a little messy, but you can handle it. You're honors, right? So it's going to be 4 times 1/2 times, now look at the base. The base is going to be 7 over radical 2 plus 7 over radical 2, whatever that ends up being. If you want to check it out real quick on the calc. Seven over radical 2 plus 7 over radical 2. All right, if you want to copy that decimal in there instead, that's up to you. I don't think it'll turn back into a fraction, though. Nope. Okay, so if you want to copy that decimal instead, that's fine. If you want to leave it there and not worry about it, that's fine too. And then I multiply it by the height, which we also found was 7 over radical 2. Okay, so 1/2, here's your base, here's your height. And if you multiply everything together here, you will find that it actually ends up being a whole number here, 98 square centimeters. Okay? 98 square centimeters. Alrighty. All right, I know that was a little crazy with the 7 over radical 2, but you can handle it. It's all typing in the calculator. That's all that was. Okay? And almost done here. I'm going to do 4 with you. You're going to do 5 on your own here. Now the question is, what happens if one of the triangles I'm trying to find the area of is not a 30, 60, 45, 45? What happens then? All right, well, now I got a pentagon. So I know it's going to be now 5 triangles times 1/2 base times height. Okay, so now let's draw out this triangle. PRQ. This was 10, which means that's 10. How about the angle here first? 360 divided by 5, which I believe is 72. Just check real quick. Yep, 72 degrees. Okay, so when you draw your height in, you cut that 72 in half, so now it's 36 degrees. Ooh, that's not a chart I'm going to fill out, right? That is not a chart I'm going to fill out, but I still have to find the height and then part of that base so I can double it. Okay, so what's been our other option all year long? If it's not a 30, 60, or 45, 45, our other option has always been, since it's a right triangle, Sohcahtoa. And that's what I'm going to have to break out here, is Sohcahtoa. Let's do H first. H is adjacent, and the 10 is hypotenuse. So if you take a look, what can I use with A and H? I can use cosine. Cosine of 36 equals adjacent H over hypotenuse 10. All right, and then I put that over 1, cross multiply. You're going to get a crazy decimal that you're going to plug in. Okay, and then how about finding X now? Well, to find X, all right, I had now X is opposite. So now I can use with O and H, I can use sine. So now I can say the sine of 36 equals opposite X over hypotenuse 10. You just want to remember, multiply by 2 at the end, right? To find the full base. Okay, so just a little, make sure when you go to your calculator to do all these calculations that your mode is in degree mode, not radians, or it's going to be a little painful to see your answers. And why didn't they check? Because you're not in degree mode. One job. All right, so make sure you multiply by 2 at the end, and then we go back up here. We have the area is equal to 5 times 1/2 base, which we're going to plug in, times whatever we got here for the height. Okay, and then I'll just do the quick math here for you. I've done this already. I thought I did. There it is. 237.8 square inches. Okay? All right. So here we go. Pause the video. You're on your own for the octagon now. Octagon. All right. Divide it. Here you go. Right? 8 triangles times 1/2 base times height. Okay. Get after, and you can assume that this is perpendicular. Okay. When you draw your triangle out, assume that's perpendicular. All right, guys, get after it. We'll be back in a second here to compare our work. Okay. So here we go. Work wasn't too hefty here because I gave you the height was 8 already. So the height of this triangle, one of the 8 triangles, the height of one of them was 8 already. The only thing you guys had to do was find the length of the base. So what I did was I found half of it I found that this angle right here had to be 22.5. Okay, because I did 360 divided by 8 and found that the full angle was 45, and I needed to cut that in half, remember, because the height cuts it in half, and that was 22.5. And then I said, all right, the side I'm trying to find is opposite. The side of 8 I was given was the adjacent side, so with O and A I used tangent, so that's why I set up this formula here. Tangent of 22.5 equals opposite over adjacent. Figured that out, was 3.31 and change, but I needed to double it to get to the full base, which was 6.6 and change. And then I plugged that back into the formula, multiplied all my values, and ended up with 212.1. Okay, so there we go for that one. Hopefully that wasn't too bad. 1, 2, 3, 4, 5, 6 different problems there. Not bad at all. And they're not going to get any different than what you just did here with me. Okay, so please reference your notes as you're doing the assignment. Thanks a lot for staying with me here, guys. Appreciate it.